Today we will briefly talk about how to add vectors. There's two different ways to add vectors. The first way is what we call the graphical method. Basically, we're just going to draw some pictures. We're going to make sure these pictures are drawn very neatly and that we take our time and draw them very accurately. Right. Two vocabulary terms that we need to know in order to be successful is we need to know what a reference vector is. A reference vector is just our starting vector. So if we look at an equation and it says a plus b, then our reference vector would be a. That's where we start. And then the second term we need to know is a resultant vector, and that's just going to be our answer vector. There are 8 steps to graphically add vectors. We must follow all of these steps in this exact order, and we must be very patient and do each step the absolute best that we can. I'd like you to take a couple minutes and read through all of the steps and highlight the important terms in each step. The best way to learn how to add vectors graphically is to just jump straight in, both feet first, and practice. So we're going to start by looking at some examples where we have a picture and we have to find the equation based on the picture. When we look at a arrow, we have a tail and a head. And when we add the vectors, we want to line them up so that we go tail to head, and so on. Kind of like a little line of elephants. They always line up by connecting the trunk of one elephant to the tail of the elephant before it. Okay, so when we're trying to figure out the equation based on a picture, we're going to look at each of the corners of our triangle. Where we have two tails together means that's where we start. Two heads together is where we're going to put our equal sign. And a head connected to a tail is where we're going to put our plus sign. So we'll go back to where we start, and we'll move in the direction of our plus sign. So the vector we start with is C plus B equals A would be the equation for this example. Okay. We said earlier that our resultant is our answer vector. So if our equation is C plus B equals A, then the resultant has to be vector A. The next part of this question is to find the direction of R, or our resultant. So just like we learned yesterday with the location of the vectors, I lined up my protractor with where we started and measured the direction of A. As you do this, you may want to draw an imaginary coordinate system to help you know where to line up your protractor. Remember that there's only two acceptable ways of placing your protractor. On the next part, we're going to take pictures of vectors that we already know, and we're going to take the equation that we're given and draw the picture from there. On some of them, you're given addition. On the example that I'm going to do for you, we're going to subtract. When we subtract, we have to flip the vector in the opposite direction because addition is the opposite of subtraction. Another way to look at that is that we need to add 180 degrees to the direction of the vector. Okay. So what I did was first I drew vector D because it says D minus C. So D is going to be our reference vector. That's our starting point. And I looked at the vectors that we were given and I just redrew vector D. From vector D, I drew a negative vector C. Again, to find, because we're subtracting, I had to flip C upside down. So while C up here is pointing straight up, in our problem C has to point straight down because we're subtracting C. And then I took a ruler and I connected where I started to where I ended. Another way to think of the resultant vector is kind of like your shortcut vector. If we could somehow magically walk through walls or drive through buildings without anything bad happening, we would be able to follow these vectors and not have to turn around corners. But in most cases, that's not how we get to where we want to go. We have to turn direction. And so all we're doing with our resultant is we're drawing a shortcut. What would be the easiest way to get there if there weren't obstacles in our way? And that's going to be our resultant R. On the last example that we're going to do together, it's very similar to the one that we just did. I already drew vector A and vector B for you. Now you have to draw the resultant and measure how long it is and find the direction of it. So I used a ruler to measure how long it was, and I got 6.7 centimeters. And then I used my protractor to find the angle, and that was 36 degrees. So each of these examples walked us through a small portion of the steps that we looked at the beginning of the notes. What you will do for number 4 on this worksheet is you will use all 8 steps together. Again, it is very important that you're very patient and do each step as accurately and as neatly as you possibly can. If we were to misdraw a vector, we would not end up in the right location. A common application of adding vectors is searching for a missing aircraft or missing boat if we know that they went down somewhere. We can take the last known direction of the plane or the boat combined with the wind or the ocean currents at that time and narrow down our search area on where to look for that missing object. So if people who are looking for those items are not drawing these correctly, they may be looking in the wrong location. Once again, all of these videos are on YouTube. All you have to do to find them is search my name, Rebecca Orcutt, on YouTube, and all of them will come up so that you can review them, rewind, and rewatch them anytime you may need. And also, if you're having troubles, I'm available for tutoring every day before or after school, as well as during 4th or 5th period lunch, unless it is crossed out on the whiteboard at the front of the room.